We collect data for neutron stars, and in particular pulsars. These are neutron stars that rotate very rapidly and have a beam of light that rotates on the star like a lighthouse and flashes each time the star rotates. And we study these kind of stars using large radio and X-ray telescopes. We try and find new pulsars in our galaxy, and when we find them, we do detailed observations of them to try and understand things like the material between the stars, the interstellar medium, and in some cases with binary pulsars, pulsars in orbit with another kind of star, we can do interesting things like test Einstein's theory of general relativity, and sometimes also study eclipses. Sometimes pulsars eclipse, so we can study plasma in very extreme circumstances. It's very hard to predict what kind of impact this sort of fundamental research will have on society. But for example, you could imagine using pulsars as navigational beacons. They emit pulsations very regularly. And in fact, there has been one patent taken out to use pulsars for interstellar navigation. You can also use pulsars to create the world's best time standard, and there's current research being done to try and do that. Currently, the best time standards are controlled by atomic clocks at national laboratories, but it turns out many pulsars are extremely stable rotators, and it might be possible to create a time standard better than even the atomic clocks. And who knows, perhaps by studying the nature of matter at very high densities, maybe one day we'll be able to have a clean energy source and you can drive your car powered by a tiny little pellet of ultra-dense neutron star matter without any kind of pollution. That's very off in the distance and maybe will never happen, but you never know.